take a look at problem C. Problem C is an infinite sum. You can see the ... But even if they hadn't shown you that, if they told you that the sum goes up to infinity, that's how you know it's an infinite sum. Now, your first term, your a sub 1, is, let's see, your a sub 1, your first term is when you plug in 1, would give you 10 to the minus 1. Remember, negative exponents just make tiny fractions, so it becomes 1 over 10 to the first power, which is how they came up with 1 over 10. So that's your a sub 1, your first term is 1 over 10. Now, notice your second term is when you plug in 2 for k, you'll get... When you plug in 2 for k, you'll get 10 to the negative second, which is 1 over 10 squared, which is 100, 1 over 100. So the question is, how do you get from the first term to the second term? How do you get from 1 over 10 to 1 over 100? Well, you're dividing it by another 10 or multiplying it by 1 over 10. So that's your common ratio, R. It is 1 over 10. You're making it even smaller. So your common ratio, R, is 1 over 10. Your first term, a sub 1, is also 1 over 10. So the formula for the infinite sum says to take that first term and divide it by 1 minus R. Well, then you have to figure out what 1 minus R on the denominator is. Remember, we've got a 1/10 we're subtracting. Well, the 1 can be rewritten as 10 over 10. So 10 over 10 minus 1 over 10 will get you 9 over 10. Remember, dividing two fractions is the same thing as doing what? Dividing two fractions is the same thing as multiplying by its reciprocal. Well, the reciprocal of 9/10 is flipping it over becomes 10/9. Well, 1/10 times 10/9. Remember, if you have a common factor between the top and the bottom, like you do here, the 2 10s, you can just cancel those out, and you end up with just the answer 1 over 9, 1/9. So again, this converges. Why did it end up converging? Is because your R was between, just like on previous problems, -1 and 1. What did it actually end up converging to was 1/9.